All right, guys, we're going to be learning about the relationship between angles and circles. Before we get to that, we've just got a few basic definitions that you need to be clear on. So make sure you're copying everything down as I go along. The first definition we're looking at is tangent lines. Tangent lines, tangent is probably a word you've heard before, but a tangent line is a line that intersects a circle once. You'll notice both of these right here are tangent lines because they intersect the circle just one time. And specifically where they intersect, that's called the point of tangency. So there's the definition, a line that intersects a circle at exactly one point. So these are examples of tangent lines. And then right next to it, these are examples that are not tangent lines. And as you can see why, this line right here never intersects the circle. This line right here in green intersects the circle at 2 points. And then this last case, this intersects the circle at 1 point. So why is it not a tangent line? Because it's not a line. It's only going one direction. A line, of course, goes both directions infinitely. The second So a tangent line is a line that intersects a circle once. The second type you need to be familiar with are secant lines. So secant lines, as you can see in the picture, are lines that intersect the circle in two spots, or in 2 points. So you can see I'm going ahead and shading these lines in and identify exactly where they intersect the circle. So there's the definition of a secant line. It's a line that intersects the circle in exactly 2 points. So we're going to look at different angles today that are formed by secant lines and tangent lines and how exactly we identify them with a couple of basic formulas. We've talked about intercepted arcs already before, and we've talked about chords already before. So we're going to skip these definitions for the moment, just because we've talked about those plenty, and we'll talk about them more here in just a second. All right, so as you flip over to this page, there's a lot here on this page, and we've already actually talked about a couple of different types of angles. And everything I talk about right here, make sure you read this right here. The key to figure out which formula you're going to use is to find out where the vertex of the angle is located. So there's several options. Is the vertex located on the circle, the center of the circle, inside the circle, or outside of the circle? So there's a lot of different options. So let's start with this diagram right here. So our little guy with no neck there is pointing to, should be pointing at this angle right here. I might label it with angle 1. This, of course, you should recognize this is a central angle because the vertex is at the center. So the relationship that angle 1 has with the arc that it intercepts, that's a x, or supposed to be, the measure of angle 1 is equal to the arc that it intersects. So in this case, we would just write right here, the measure of angle 1 is always going to be equal to whatever that arc measure is. So that one we should know. And then we should also know when the vertex is on the circle. So that's the second example that this little guy is pointing to. He's pointing to the vertex being actually on the circle. So same way, that angle right there, we're going to call angle 1. That's a 1. And we're going to call the arc that it intersects x. And an inscribed angle, we know the measure of angle 1 is equal to 1/2 x degrees. Or another way we could say it, we could say x divided by 2. So the same thing as taking half of x is dividing it by 2. So on the center and on the circle, we already know those two. There's two new ones that you need to be familiar with. And there's a lot of cases. The first case is outside the circle. And below outside the circle, we actually have 3 different examples here. We have 2 secants right here, as you can see where my marker's going. These are 2 secants because they intersect the circle in 2 different spots. Here we've got a secant and we've got a tangent line. And then at the bottom we've got 2 tangent lines because they both intersect the circle in 1 point. But in all of these cases, the vertex is on the outside of the circle. So if the vertex is on the outside of the circle, we can say that that angle right there, angle 1, it's the angle that's at that vertex that our little necklace guy's pointing to. And that angle actually intersects the circle in 2 different spots. It intersects the circle right here, and it intersects the circle right here. So we're going to use both of those green arcs to identify angle 1 and some problems here in just a little bit. So the formula to find the measure of angle 1 that you need to make sure you get down, the measure of angle 1 is equal to the big arc, which is what we're going to call it for now. Try to keep this on that line if you can. Mine's going to, looks like it's going to go off the page a little bit. All right, fixed it. It's the big arc minus the little arc divided by 2. And you'll use this formula, a similar formula here in a second. The big thing is, though, when the vertex is on the outside, you subtract the 2 arcs and you divide by 2 to find that missing angle. And it's important that you do the big arc minus the little arc, because if you don't, you'll end up getting a negative answer, and you can't have a negative answer, obviously, for an angle. You can't have an angle that's negative 60 degrees. All right, so our final example is a vertex that's inside the circle, but it's not at the center. Like we've already seen a vertex over here that's inside the circle, but that's at the center. So there's a different relationship if it's inside the circle and not at the center. So again, I'm going to take an angle, and it doesn't matter which angle we pick here, because we've got a couple of different sets of vertical angles. So I'm going to say that's angle 1 right there. And I'll look at the 2 arcs that are associated with that angle. So it's these 2 arcs right here. So to find the measure of angle 1, this is the formula. So it's the 2 arcs added together divided by 2. So the formulas are very similar. The only difference is one has an addition sign and one has a subtraction sign. A really handy way to remember which one has the addition sign is, if you actually look in the diagram right here, this actually looks like a plus sign on the inside of the circle. So that's a way that I use that helps me memorize this formula. If there's a plus sign in the middle of the circle, you're going to use this formula right here. So these are formulas you're not going to have memorized right away. You're going to have to practice a lot of problems before you get these formulas memorized. So we're going to practice some here together, and then you're going to practice some on your own in just a little bit. But we're going to skip the rest of this page, but make sure you have these 4 formulas. You should have the first 2 that we talked about right here and right here. You should have those 2 formulas down by this time. It's the new 2 formulas that we're going to practice mostly. So we're going to skip ahead. Again, pause if you need to. We're actually going to skip to the last page. We're just going to go straight to working out a lot of different examples. And I'm going to kind of cherry pick problems here. I'm going to kind of skip around, but I do want you to do all 15 of these questions ultimately. So let's start with number 1. Seems like a logical place to go. Number 1, again, you want to identify where the vertex is first. That tells you which formula you're going to use. So the vertex for number 1 is actually on the circle. And you don't have to write that down, but I wrote that down just so you see. So the vertex is on the circle. So I'm going to go back here to the formula page and see when the vertex is on the circle, I'm going to use this formula right here, which you actually should be familiar with. This is just the inscribed angle. In that case, it's half the arc that it intersects. So this one's pretty straightforward. It intersects a 54-degree arc. So that means it is half the arc that it intersects. 54 divided by 2 is 27. So that's your answer to number 1. Try to do number 2 now. Number 2, very similar problem. The vertex is on the circle. The only difference this time is they give you the angle. So they give you the angle. You need to find the arc. Remember, the angle is always going to be smaller than the arc with the inscribed angle. So that tells me we're actually going to have to multiply 35 by 2. In this case, our answer is 70 degrees. The angle is half the arc that it intersects. All right, so getting to a new problem is on number 3. We got a new problem here. The first thing I want to do, if I can, always on these problems, is figure out all the arc measures of the circle. So I know that this arc measure right here is 100 degrees in blue. Tells us that. This arc measure is 120. This arc measure is 90. I should be able to find this last piece right here by adding these 3 measures up and subtracting from 360. So go ahead and do that. So if you can read my writing there, 50 degrees, add them all up, subtract from 360, that piece is 50. So now we want to find x. So again, we want to identify where the vertex is. So in this problem, you see the vertex is on the outside of the circle. So we want to go back to the formula page and see which formula we're going to have to use. It's okay to go back and look at the formulas. You're not going to have them memorized right away. So I'm going to go back. The vertex is on the outside of the circle. So I see very quickly, if it's on the outside of the circle, I'm going to use this formula right here. The big arc minus the little arc divided by 2. So the big arc is 120. So that means x is going to equal the big arc, which is 120. That angle intersects this arc, minus the little arc that it intersects, which is 50, divided by 2. So 120 minus 50 is 70. 70 divided by 2 is 35. And that seems like a reasonable answer too. If you look at just look at it, that looks like at about a 35-degree angle. So x equals 35 is our answer to number 3. All right, I'm going to skip 4 for now. I'm going to go to number 5. Just to identify that real quick on number 4, the vertex is on the circle on number 4. So that's a problem we've done a lot of. Number 5, again, the vertex is on the outside of the circle. But again, find every part of the circle that we can to begin with. We know this part in purple. That part of the circle is 175. This part right here is 110. So add those 2 measures together, subtract from 360, and that will give us this part here that I've bolded in black. So 175 plus 110 subtracted from 360. So doing the math in my head, do not have a calculator with me. So hopefully that is correct. I'm sure one of you will correct me if I've made a mistake there. So now again, I'm going to use the formula for when the vertex is on the outside of the circle. So that means we're going to add the 2 arcs together that it intersects. Or I'm sorry, we're going to subtract the 2 arcs. We just did this, a problem like this on number 3. So that means x is going to equal the big arc that it intersects is 110 minus the little arc that it intersects is 75 divided by 2. So x equals 17.5 degrees. Obviously, these are not all drawn to scale, so you can't always just look at it and see if it makes sense. I prefer the problems where they are drawn to scale, but that's our answer for number 5. So we're going to skip number 6. Number 6 is, again, the vertex is on the outside of the circle. You need to find the missing angle measure of the circle, which I've bolded in purple there, before you solve for x. But it's just the formulas exactly like we did on 3 and 5. Moving ahead to 7. So 7 can be a tricky problem if you're not careful. So the angle we're looking for, the vertex is inside the circle, but that's not at the center. We know it's not at the center because if it was at the center, they would have drawn the dot to begin with. And we can even just look at it. The center is somewhere probably a little bit lower than where those lines intersect. So to find x, the two arcs that we need to know typically to do this formula are this arc and this arc. We don't know what they are, and there's really no way to find those two arcs without just guessing. So instead, what we're going to do is we're going to find this angle right here. We're going to call it y, and once we find that angle, that'll help us find x in this problem. So again, look back at your formula sheet. If the vertex is in the circle, figure out which formula we're going to use. Remember, here's a hint to kind of make a plus sign in the middle. So there's going to be a plus sign involved in our formula. So to solve for y in this problem, it's going to be the two arcs added together. And the arcs that they give us are 125 and 117. It doesn't matter which one you write first, since we're adding them together. It only matters if you're subtracting. So there's the formula to find y, 125 plus 117 divided by 2. So I can double check my math to make sure that is correct. Make sure you're doing these problems too. The more you practice, the better you get at them. So that angle right there is 121. So that means x is going to be 180 minus 121, since those two angles form a straight angle. So to find x, just take 180, subtract 121, and I believe that is 59 degrees. So that is our answer for x. All right, so hopefully you're getting a little bit. If you've got further questions, please ask. This is not meant for you to completely understand this after this video, but hopefully you're gaining some understanding. But again, if you've got further questions, please let me know. The last one I'll look at is, we're going to skip ahead. Well, first off, number 10, I'm not going to work this one out. But what you need to do to find x, first off, the vertex is inside the circle. So you're going to use the same formula we just used. The two arcs that we're going to use to find our answer are this 15-degree arc, and then whatever the measure of this arc is. And we can easily find this arc right here by adding up these measures and subtracting from 360. So that's kind of the strategy you want to go about solving number 10. The last one real quick is number 14. Number 14, if you look at this one carefully, they want you to find the measure of angle ACD. Angle ACD is this angle, and it intersects the circle in between those two green dots. Now, if you look at the angle they give us angle ABD, which actually intersects the exact same arc. So if they intersect the exact same arc, that means they're both equal to half that arc. We don't really know what that arc, half that, or we do know what half that arc is. They give it to us. It's 86 degrees. So since they both intersect the same arc, they're both 86 degrees. All right, keep working on this and let me know if you have questions. Good luck.